Hello, everybody. I'm Melissa McKay. I'm a developer advocate with JFrog, and I'm here today with...
And yeah, hi, I'm Damian Curry. I'm the technical director for community alliances with NGINX.
Awesome. We're here to talk about updating our application. We have this wonderful application out there we've built. We have all these processes in place. We have some automation put in there, but now there's some stuff that we want to do with this thing, right? And I have a couple things I wanted to bring up. There are some security issues that have to do with some old libraries that we need to deal with. And also just keeping things updated, fresh so that we can avoid security issues in the future.
Yeah. And, taking advantage of all this easy way we can do releases and updates. So we got to figure out how we actually do that.
Yeah. And we need to take advantage of it, right? Another one. So those are updates we have to do. We must do just to keep ourselves safe and responsible. And then the second update that I wanted to talk about is an actual addition to the product itself. So this product is just more background on it. It's basically for veterinarians out there. It stores some basic information about pet visits and pet owners. One thing it doesn't store currently is the ability to put in, those tag numbers, like when you can chip your pet. And I think it would be really nice to add this feature so that the vet knows what that chip number is when an animal comes in.
I will say, as someone who's found lost dogs before, it's very helpful that they have those and are able to find out who the dog belongs to.
Yes. One thing those things don't do, though, is they don't have GPS. Your animal still gets picked up, right? But at least you have a way to recover them. But I would love to know where mine wanders in the neighborhood. That would be nice to know. Anyway, these are things we want to update our application with, and we have a couple of things we need to talk about. And before we get too far into it, since we have this system all set up, I want to go back to best practices for continuous delivery.
Yeah, I think that's always good to, go back there too, because you got to stay on top of it and make sure that, when you can look back and you can see like, okay, what did we implement this the correct way? And how do we even know that, right?
Yeah. Are we doing the right things? Are we just, doing it just because everyone has told us to, and these are the buzzwords we're following, and these are the, the last team I was on worked this way, so now we're going to work this way. We know where that ends.
And there's a big difference between, it's like, well, it works, right? Obviously it works, or else it wouldn't be running. But, just because it works doesn't mean it's being done the best way it could be.
Right. Are we doing it well? Well, as part of the Continuous Delivery Foundation, I had the opportunity to meet a gentleman. His name is Terry Cox. He is actually really involved with a special interest group there called the Best Practices Special Interest Group.
Oh, great.
And they've done a lot of work out there already just to define what continuous delivery is, give some folks some advice on the best way to utilize it, how to implement it, and what your expectations are, what they should be, that kind of thing. And he goes pretty deep. I say he, but it's an entire group that does this. I bring him up because I would love to bring him into our conversation and talk with him about this. What do you think?
Yeah, I think that's great. I mean, it's always good to get, opinions for as many places you can get, which is the great thing about all these SIGs and all these working groups, to get different people with different backgrounds and different experiences to share what they've learned. Yeah.
And sometimes they go a little bit further than the technical side. They get into, the bigger picture, the business side, which can really help us, especially when we're forming our expectations on how this should work.
Yeah. Well, and being on the technical side, it's really easy to kind of get stuck in the technical details and not look up and go, oh yeah, there's a business we're supposed to be running here, huh?
Right. Exactly. Okay, well, I'm going to contact him. Let's take a minute and let's see what he has to say about best practices before we start jumping into all of the updates that we want to make.
Great.
Hello, I'm Melissa McKay. I am a developer advocate with JFrog. I'm here with Terry Cox today. I have met Terry through various initiatives, one being the TOC of the CDF Foundation. as well as I'm aware of some contributions that he's made to best practices, the best practices special interest group. And he has some really, really good thoughts. Terry, I'd like you to introduce yourself and let our audience know who you are, where you come from, and what your background is.
My name's Terry Cox. I'm an architect and CTO working in the technology space. And a number of years ago, I got involved with the Continuous Delivery Foundation and have been helping out wherever I can. Most recently, over the past few years, I've been co-chair of the Best Practices Special Interest Group. And what we try and do there is just collate all the experience that's out there from teams that have been working in continuous delivery environments for a long time now, and try and take all of that mass of knowledge and turn it into just an understandable bundle of here's the important concepts. This is what you really need to get your head around. And here are the shortcuts and the things that you can learn from the benefit of other people's mistakes.
This is exactly why I'm looking forward to speaking with you and asking you a few questions. Damian Curry with F5 and myself, we're working on a development project together. We're walking through and we're discussing the various choices and challenges a development team will encounter when developing and deploying, in our case, a simple web application to the cloud. And I come from a developer background. Damian comes more from the operations and infrastructure side. And we're about to walk through our first updates to our project after it's been deployed. We're discussing both a maintenance update and a feature add. And we, of course, have our ideas about the technical approach and how to be most efficient. But, we've been throwing around the terms CICD for a while, and we both thought that maybe we ought to take a step back and look at maybe the origins of CICD, where it comes from, why we should even consider it, and actually, what does CD even mean? And I think you have some really good thoughts on that subject.
Yeah, so this is a really interesting and quite challenging question, because a lot of people come to CICD as an engineering process. So it's that step of getting some software built and out of the door. But the CD in CICD is really continuous deployment. So it's the idea that you continuously integrate all of your software contributions and then immediately continuously deploy those into an environment. Now, that's subtly different from the bigger picture, which is continuous delivery, which is where you're actually thinking about the end-to-end problem of delivering product to customers.
Okay.
Because continuous deployment as part of CI/CD is about delivering the next chunk of software into the next environment. But that's not necessarily always going to be a production environment facing a customer. So some people use CI/CD as a way of deploying into test environments, and then they use manual testing processes and release as a separate stage. Now, that's different from what we consider to be continuous delivery, which is where what you're thinking about is, okay, I'm a business, I'm interested in serving my customers, and so what I need to be able to do is take the next product idea and get it in front of my customer. And so my definition of done is that the code is running in a customer-facing environment, the customer is using it, and it's got no major flaws with it.
That makes sense. So I'm thinking for our initiative, since it's just Damian and I right now working on this project, we kind of wanted to make sure we have the right thing implemented engineering-wise, but also make sure that we're paying attention to the reason behind it, because at some point we will be opening up this project to other contributors as well. And then we're going to be having all of these different business concerns that are more than what we have talked about a lot with this project. Okay, so for one of our updates, we have a feature add. And I think what you described is, getting that feature in front of customers so that they can review it, make sure that it is actually working correctly, but then also make sure it's something the customer even wants. And that's a little bit different. There's a different environment, right? When you're talking about different kinds of organizations. I think you have some thoughts about, whether or not you're starting out as a startup versus a very established application, for example. What are the differences there, and why would it be more difficult for one type of organization than another to establish this, even in the engineering side of things?
Yeah, so this is actually a critical part of learning to be successful at software delivery, because there's an anti-pattern here that's very easy to slip into. Because if we are looking at this as an engineering problem and thinking about the outputs of the engineering team, then you can get very, very focused on features, and you can get very, very efficient at building new features and shipping them. But if those features are not aligned to what the customer actually needs, then you just got really, really efficient at building the wrong thing. And that's a very common failure mode, is that everybody's working as hard as they possibly can, and they're delivering things that the customer doesn't want.
Right.
So
I'm examining my past now, and I'm thinking this is a lot of times in my career that this is exactly how it's worked.
Yeah. So I always recommend that you take a step back, and think about why we're actually here. Because we're not here to write software. We're here to build products that solve a problem for customers. And we use software and we use machine learning to do that. But the software is not the outcome. It may be the output, but what we need to think about is what's the actual outcome that we want to achieve.
I see.
And so this is why we have a process of product commercialization that in successful organizations is very focused on product discovery, because the reality is that you don't know what the customer actually needs. You might have a guess at what the customer needs, and the customer might have an opinion on what they need. But in practice, neither of those are usually what the product actually needs to be in the end. And so you've got two possible ways of approaching this. You can either have a strategic approach and say, well, we're going to spend a year planning this product, and we'll hire lots of people, and we'll do a great big Gantt chart, and then we'll hire a big team, and we'll build all this software, and we'll test it, and we'll do lots and lots of quality controls, and it will be absolutely perfect. And then we'll show it to a customer for the first time and find out if they actually want to buy it or not.
Right.
Which is a huge investment and a great big risk. Nowadays, what tends to be a more successful strategy is saying, well, what we're going to do is we're going to think about a problem that needs solving. And then we're going to find a couple of customers who've got that problem and they know the pain that it brings. And we'll work with them in a production environment with real data to do some experiments to validate our understanding of the problem and start to demonstrate that we can do something that addresses that problem. And so at that point, what you want to be able to do is define an experiment, write some code, put that code in front of the customer and have them test it to tell you whether it's doing the job right or not. And then adjust it and try it again until you hit on something that actually solves the real problem for real customers.
So it occurs to me, in order to do this, I'm just thinking of deployment frequency metrics, thinking of like, how do we usually determine whether we're successful or whether we're doing the right thing? And there's some metrics out there that are well known now, the DORA metrics. And I'm thinking just even this deployment frequency, this is about being able to get stuff in front of the customer frequently and quickly in order for them to make decisions so that we can move on with the business goals, right? Am I thinking that correctly?
That's right. So this is why continuous delivery exists as a methodology, because say you're a startup, you found a product that, or rather, you found a problem that you think you can build a product to address. You found a couple of customers. Well, now you've got a certain amount of investment and a certain amount of customer attention span in which to prove that you can do something that the customer wants. So if you spend all of that money and attention span building one feature and then you give it to a customer right at the end, you've bet everything on that one shot, which is really high risk. So instead, what you want to do is take much smaller bites at a much faster cadence and say, look, here's our first idea. Here's a feature we think addresses your need. Build it in 3 days, put it in front of the customer, get their feedback in a couple of days. And they'll say, oh, it's a bit rubbish. And actually it doesn't really do what we want. What if it did this? So then you do another 3 days of, right, well, let's make it do that instead. And then you put it back in front of the customer again. And you keep iterating until you run out of money, the customer gets bored and goes away, or they start throwing money at you because you're solving a big problem for them. And when you get to that stage, of course, then and only then do you scale up and turn this into a full product. But what that means is that you, as a business, need to get really good at very quickly going from making a hypothesis to defining an experiment to test the hypothesis to building some code to demonstrate it to running that experiment with the customer, measuring the outcomes, and then changing your behavior and iterating again. And the faster you can do that, the more bites of the cherry you get with the customer to prove that you've got a valuable product. And so that's why we, within the DORA metrics, look at deployment frequency, because if you can deploy every day, you can, in theory, do a new experiment every day, and therefore get many, many bites of the cherry before you run out of runway.
The same could be said, I guess, for recovery. How soon you can recover from errors.
Yeah, so recovery is an interesting one, because if you're saying, well, we're going to run experiments in live environments with real customer data, well, that's terrifying, because it's an experiment. It's not production code. You know that you're just writing something to test. So in a traditional way of developing software, that would be very, very frightening, because you would be committing high risk code into live environments and very scared of it going wrong. But if you change your mindset and say, instead of, well, this code must be perfect and we'll just spend forever refining it until it is perfect, you instead say, we know that this code is always going to fail in some way, but what we're going to do is minimize the impact of failures so that they don't hurt anybody. So we'll do much smaller bites. So we won't try and do everything all at once. Each deployment will be a fixed scale, and we will understand the impact of it. And we will expect it to go wrong, and we will prepare so that we're testing it as soon as we've deployed it. And as soon as we get any sign of anything not doing what we expect, we will roll it back to a known good state, so that only 1 or 2 people might be impacted by something if it does go wrong, rather than everybody being impacted for weeks.
Wow, Damian and I have a lot to think about. It is really interesting to consider the other side of the equation. I'm so used to coming at it from the engineering standpoint, and I get the numbers, I get the metrics, I get the efficiency of the pipeline, but really making that connection to understanding that these have meaning more than just numbers that can be manipulated by engineers, because we're very good at that. We can manipulate these numbers, make them work for us, and set ourselves up for success. But in the end, if we're not meeting the business goals and objectives, that's an issue. So I can see some value in making sure that teams understand the why behind what they're doing. And I think you've touched on that very well. Well, thank you very much.
I was just going to say that there's one other piece that it might be valuable to think about, and that's understanding the lead time metric.
Okay.
Because we have a tendency on the engineering side of things to say, well, lead time is the product manager's given me a card to work on, and I've done my bit and shipped it, and so that's my lead time. But that's not really what lead time means in the context of continuous delivery. And there's a very important difference here, because in a practical situation, lead time is the distance between establishing that you need to run a new experiment with customers. So it includes defining what that experiment is, what the success criteria are, and then writing a story and passing that story on to the engineering team, doing all of the engineering, putting that story live in production, having customers using it, and getting metrics data flowing back from that story. So it's only at the point when you've got metrics flowing back into the system and can see that it is the experiment is running, that's the end of your lead time.
I see.
So your definition of done is a lot wider, but it also has implications, because if your organization as a whole is not set up to run continuous delivery, but you've got an engineering team who do want to try it, you nearly always fail as a team, because that lead time definition requires the whole organization to be operating at the same cadence. And so if you haven't got that buy-in at a C-suite level, and you haven't got someone knocking down all the barriers, you'll find that the organization will fight you in your ability to deliver at the cadence you need.
Definitely been in situations like that before, and that's a really, really good explanation of exactly what happens. And especially when you get a bunch of developers who've learned about this, they're excited about it, excited to get it implemented. But again, there's a whole business side of this that needs to be considered and nurtured as well. You've enlightened me today. Thank you so much for talking with me. I'm excited to share what you've said with Damian, and we'll continue forward with our project with these thoughts in mind for sure, and hopefully be able to share them with others who can benefit from them as well. Thanks very much, Terry.
My pleasure. Thank you for having me.
Well, what did you think, Damian?
No, I think that was great. It's really an important thing to look back and, like we were saying, there's a reason that you build these systems, right? And besides just it's the cool thing to do, or it's the buzzword that everybody talks about. So it's really good to look at that and go, oh yeah, there are ways, in being able to pull that information out, right? And have those kind of tangible metrics of, being able to show how well it's going and how well it's actually working, rather than us going, well, it deployed, it didn't blow up in my face, so it must be good, right?
Right. Exactly. I like, just how much focus he has on DORA metrics, what they are and what we should be using them for, and what they really mean. I know before I really got into them, and before I, got into the background, even read the book, Accelerate. Have you read that one? The Science of Lean Software and DevOps?
I was gonna say, I've not gotten to that one. It's on the list though.
It's a good one. Before I read that, I really didn't buy into it completely, especially the, increasing your number of deploys to production. That one I balked at initially, just because I misunderstood what that means. Having the ability to deploy frequently doesn't mean that, you have to deploy frequently because you've made mistakes and you need to correct them, right?
Yeah. Or just as a way of, don't want to just use them for numbers too, and pad your numbers and have every commit be a tiny little change in the code just to make it look like you're doing it more, right?
Exactly. I still am a little hesitant, I guess, I don't know, there's buy-in, and then like you said, there's manipulation of the numbers. So
exactly.
I always worry about that. Once you start measuring something, it seems like we all tend to figure out ways to manipulate that system.
Yeah, I really like the idea of looking at the percentage of failures in production. And I think that production piece of it too is a very important part, because, I've run into it before where people are going, wait, why are we doing this CICD thing? Like all of these tests are constantly failing, but they're failing in dev. And it's one of those things that's like, no, that's where we want to see the failures. Now when we get to production, if we're seeing a bunch of failures there on new releases, then yeah, we've obviously got a problem. So I think that's a really good one that I just really like to make that delineation, right? Because it is that in the lower levels, you do want to see that failure because that means it's being caught. But you definitely don't want to get it at the production, and that's why we've got all these different stages and different environments, and being able to monitor that and see how hopefully see that decline in failures as you migrate up through the stack.
Yeah. Well, after it gets to production, I liked what Terry had to say about the whole purpose of this too. Like once something gets into production, you need to decide, was this a good thing to add? Is this something that we need to monitor and see, how our customers feel about it, if it works, if we need to make changes. Just that whole idea of making small changes so that we move in the right direction of the market. Obviously,
kind of being able to
stuff is open source, but I mean,
definitely kind of walking your way into the features, right? You don't want to make that assumption and go, oh, everybody is totally going to love this, spend a bunch of time in development effort, and then realize nobody cared. When instead of being able to go like, oh yeah, here's a little bit and a little bit more, and then you see that uptake, and then you're obviously like, okay, cool, this is something that is worthwhile, let's go all in. But yeah, having that ability to do that small, because it is again that you think it's like, oh, we're just making releases for the sake of making releases, but especially that being able to separate the different pieces, kind of goes hand in hand with the microservices idea. So you're moving those dependencies so you don't have to affect everything with one change. You can have it isolated into a smaller code base that again makes this whole process way easier to deploy and update and test those things out and see what happens.
Yeah. So for the updates that we're making, and I'm curious how you feel about this subject. So we talk a little bit about just release management. Being able to automatically do this, or if you're behind a machine that needs to concern themselves with promotion and backward compatibility and things like that, I struggle a little bit with this idea that the more often you deploy, the better you are. Just because, how do you manage that? For example, we know what we're going to add for our little project. We're just going to add, a field and just a small feature. But let's say in the background, you have a whole marketing department that's concerned with how do we promote this? When is it actually going to be delivered? And then being able to track, any bugs that are associated against it. And then for the technical team to worry about that and fix those as they come in. I don't know how to make those two worlds work together. Yeah,
it's definitely a tough problem, because in one hand, the whole idea of this stuff is that it's automated and it can just go, and it doesn't take, it's gone are the days where it's like, okay, first I'm going to take this server out of the load balancer and I'm going to log in, I'm going to, do the deployment, test it, and manually put it back. But at the same time, it's scary when you're just blind, when stuff's blindly going to production and nobody maybe even knows, right? So it's definitely finding that balance. And what I've always done is, and I think in these situations, there's kind of different levels of deployments, right? There's some that are, little ones, whether they're bug fixes or, updates for security patching or something like that maybe those can run a little bit more. But then if you're doing like a big feature release, obviously you want to have a little bit of a gate on that, and, maybe even do a slow rollout. So having that balance it's always going to be different for every application, just because they're all behave a little different. Every organization's a little different. But yeah, it's definitely a fine line to kind of find there of how much do we trust the automation and just want to let it go do its thing, and then when do we need to step in and go, okay, this change, we need to be a little bit more, there's too many moving pieces, right? Like you mentioned, when you're doing a database update or,
Right.
changing a schema, because now you've got not just the code that's going out and its requirements, but now you also have to time, how do we make this change in the database? When do we do it? Can we do a database change early and then do the application change later? Or does it have to be very tightly coupled and timed really well? So these are definitely the more complicated ones, that's for sure.
We need to think about it differently, because there is an old style of doing things where you have, that list of features that we need to develop and get put out there. And then we may even hold back some of our development and some of our features because it's not ready yet from a business perspective. Mm-hmm. And that's where I kind of like these ideas of feature flagging.
Yeah.
I know that's much more simple sounding than it is. Some cases it's pretty difficult to feature flag stuff, but it definitely is a good way to think of it. Something that can actually be delivered and deployed, but not actually activated yet until the business is ready for it. Mm-hmm. I've always thought, those approaches are really interesting. I wonder if we could do that with ours. If we're going to make an update, a database update, if that would be possible to feature flag somehow the UI part, so that when we're ready, we can activate it.
Yeah, that's always the good one too, is being able to have that flagged, and whether it's being not hidden, but hiding in the application itself, or even that the application maybe is fully functional, but we're doing something at the front that's routing it. Maybe we have two versions. We have an A/B deployment, which makes it even better, because then we can real-time test in production in those environments, but have it so that, say you have to inject a special cookie to get to that site, or maybe it's locked down to, our IP addresses. So if it's a request coming from us, it'll know to route it to the new one, but the general public gets the old version. So having the flexibility there, and, especially, with that routing logic, can make it gives us multiple options of how we want to go about making sure that it doesn't get released before we're ready.
Yeah. It's also an ability to kind of get some real-time reaction from the market or from customers, or even, maybe beta customers that have agreed to experiment with you. Yeah. And this is different than testing in production. It's more of evaluating the solution in production, right?
Yeah. Yeah. And having that flexibility to decide how we want to do it, especially when you can do it, like I said, by, whether it's a cookie or a flag in a user account after they log in, right? That sets that metric in the request. And then we can handle that logic at whether it's, at the NGINX level when it's coming into the request, or we can do it at the application level. Just having that flexibility is definitely a plus too.
I like that you brought up the database change, because one of the features that I was suggesting obviously is going to involve a database change.
Yes.
So how we go about that is going to be interesting. In the old days, I say the old days, it's going to age me a little bit. I've been on teams where we, have a database administrator, and when we're ready to deploy, we've got to make sure that they are in the loop of what we're doing. And most of us, wouldn't have access to the production database. So you've got to make all those connections, make sure everyone's doing everything at the right time. And it can get a little bit complicated. Obviously, ours is not that complicated. We are in control of our own database, and we can make these decisions. But
and on the plus side, I at one point in my life was that database person. So I have done that side before too. And thankfully we're gone are the days where everybody's like, okay, everybody get online, and we're going to say, okay, database person, you go do your change. Okay, that's done. Okay, now app, go do that. Okay, now switch do the load balancer change, right? And
exactly. So I'm always looking for ways that this could be easier. And I've had the experience of building something ad hoc that, worked for our team, and it did ease things a little bit, but I kind of would like to go out there and look for a tool that might help us out with this. And there's one I have in mind. Obviously, I'm not going to argue over implementations and stuff. It's just an idea. But Liquibase interested me a little bit, and I wondered if it would work for our project. I have a person at Liquibase that I'd love to talk to about this before we jump into it and try to use it. One of the things that I would use to evaluate this tool is how easy it is to implement after we already have our database out there, right? We already have some data out there. We already have the process in place. Now we want to add this tool on top. And so many of, documentation and stuff is going to teach us how to do it from scratch with a fresh project. And I want to see how easy it is to do it with something that is already out there.
Yeah. And that's a great test for the sort of tools, because, that has always been the thing is, even in this new CICD space, the database is always that thing of like, don't mess with it, right? Like that's the backbone. If that breaks, we're hosed. And being able to, having the tooling that allows you to make those changes and not have to start at zero is great.
Well, let me go out and see if I can get in touch. We'll see what he has to say.
Awesome. Can't wait.
Hey, everybody. I'm Melissa McKay. I am a developer advocate with JFrog. I'm here today with Robert Reeves. Robert, would you like to introduce yourself? Let us know what your expertise is.
Well, I'm not an expert, but I am Robert Reeves. I am co-founder at Liquibase, which is a DevOps for the database company. We are based on open source, and we help some of the largest banks, insurance companies, consumer packaged good, just the biggest of the big, solve their database update challenge in this brave new microservice world.
I'm so glad to have you here with me talking about this, because I'm in the middle of an update on a project. And just to give you some background, we chose an existing project. I'm working with NGINX F5, Damian Curry. He and I have been working on this project together. We want to go ahead, and we're at the point where we need to make some updates. One for security reasons, and then another is a database update because it is a feature that we want to add. And this is a pet clinic application for veterinarians, and we want to be able to add a field for them to put in something like a chip number for their pets. Obviously, this is going to involve adding a column. Now, I was looking around for how to better handle this process, because I've been on teams in the past where every time we have database updates, it's kind of a mess, especially if there's more than one. Like if we have developers working on different features, different parts of the applications, at the end of the day, we all need to merge all that together and get everything out to prod. And sometimes it involves getting a database admin involved, and then there's a bunch of scheduling snafus, and it gets really complicated. So,
for sure.
Do you have a suggestion? And I know you do.
Well, I mean, the first thing I would say is you are not alone. This is a endemic problem in software development. We've had it for a while. We certainly had it back in the day when we were doing server-side scripting, building websites in the 90s. We certainly had more of this challenge with things like Java application servers, where we were able to quickly put out releases, far quicker than server-side scripting. But now it has gotten just untenable. I mean, it has gotten really bad because we have moved as an industry to microservices. Kubernetes won, thank God. And it's but now we're empowering our development teams to go ahead, update your service, update that container, get it out, no problem. And we have not been able to apply that same model to our friends over in database land. They're still manually updating. And those two models just don't match up, where we have empowerment of individual teams to do what they think is best. And we're not doing that on the database side. And so we're constantly requiring our database administrators to come in and manually review stuff. So on the application side, everything's automated. It's great. It's a brave new world. It's awesome. And we're killing our DBAs. And frankly, it's rude. It really is rude, because on the development side of the house, oh, it's great. You know, it's, oh, look, I just did this update and now I'm going to go get coffee. And on the database side of the house, they're still ticket driven. And so we need to find a way to put those two paths together. We can't have automation on one side and manual for the database, because we're just crushing them. Again, rude. So yeah, and that's what we saw early days with Liquibase. We were having challenges in our individual lives. The project co-founder, project founder, the open source project founder, Nathan Voxland, he looked at it and he said, man, this sucks. I want to fix this. And released Liquibase. And we started to see the, we're like, okay, this is good, but this is actually bigger problem than just the handful of databases that Liquibase initially supported. And what we found at Liquibase is that not only are we going faster on the application side of the house, but also we're seeing an explosion of different databases because we've allowed developers to build that microservice however they want. They can, as long as they adhere to that API contract, they can build it on whatever platform they want, whatever database. So they choose the database that works for them. Right. This has caused our friends over in database side of the house to just be overwhelmed. Used to be Oracle Shop, SQL Server Shop. You use the database based on who your CIO played golf with most recently. Right. That's how we made decisions. Now, not so much. Devs are like, nope, we're using this one. We're using a graph database. Sounds good. Awesome. And so we're causing problems for those folks, not only with the speed at removing an application, but also the number of databases. So that's the problem. And you're not alone in experiencing this.
Right.
So I think we want to find out, well, how do we fix it, right? Is that
right? Yeah. How do we fix this problem? Because I'm so used to the old way of doing things. Sometimes it's hard to, get my mind wrapped around a new way, a better way, automating things. So the first thing is we probably need developers to know SQL. I've got a personal beef with this. ORMs have their place. There's something, they have their place and they're useful, but I prefer being able to just, if I need to add a column, I know the SQL to add a column. If I need to delete something, I know how to do that. So
why
trusting the
developers,
right. Trusting the developers to be able to go that far at least, and then to be able to track those changes, and then keep those changes in source control along with everything else. I think that is pretty valuable. And that's something that Liquibase does, right?
Well, it does. At its most basic functionality, the open source Liquibase has an artifact called the changelog. We're very creative with our naming. And so it is a list of things that need to happen to the database, because databases, you need to make changes serially. Unlike the application, we can't just blow it away and recreate it because we lose the data. So we need to evolve. We need to migrate this database over time. Now, you might say, well, Robert, that's just for relational databases. I'm using NoSQL and I don't care. Well, there are configurations in NoSQL land, creating collections, things like that. There is global settings that you need to set in NoSQL land, regardless of what that is. And so what will happen is you will say, okay, maybe the first change set in this changelog will have the initial pet clinic schema, all the things you need, customers, pets, all that stuff, and the connections between those tables. All right, cool. Then you'll have second change set, which is add the column. Great. Now, what Liquibase will do is when you say run, now we're going to imagine just Liquibase from the command line. We'll deal with integrations into our CICD pipeline in a second. But okay, I run it from the command line. What Liquibase will do is connect to that database, same way you connect if you were going to execute a script, username, password, or whatever authentication you're using.
Okay.
And it'll look to the database and it'll say, hey, what version are you? There's some meta tables that Liquibase puts in there that says, I'm version 1. And that tells Liquibase, so we've already created the initial pet clinic changes, the customer table, the pet table, all those things. And then it says, we have not done change set 2. We haven't added this column, and it will run that. It will add the column. Well, let's say, okay, I like that database change, but I needed to do another update on this change that I'm doing. We run it again, and Liquibase says, oh, there's nothing to change here. We're good. We're okay. You can also run this against an empty database, and it'll recreate all that stuff. So for developers, that's handy.
Nice.
Now, where this really benefits when you integrate this with CI/CD is Liquibase is idempotent, meaning, I love that word, meaning that you can just run it over and over again and get the same result. So Liquibase, every time you do CI/CD, so I don't care what you're using, GitHub Actions, who knows, and you say, all right, let's run the Liquibase GitHub action. It's going to update the database, and then it's going to deploy these new containers. Great. Maybe do some automated testing. Maybe we hook it up to a GitHub action that looks at, oh, you did a PR? Well, let me fire up some containers, run this stuff, do my automated testing, and then give a thumbs up check mark that it passed automated testing. When it comes time to deploy to later, maybe we've got a UAT place, stage, maybe we've got, of course, production. Liquibase will say, I need to update this stuff. And you're doing it over and over again with the same workflow. This is powerful because if you're going to have problems, you're probably going to have them in development.
Right.
You're going to catch them there because we're taking the human element out of this. Like the past 5 years, every time we've had downtime in AWS, in US East 1, it's always manual change. So we want to get humans out of this. We want to put humans in the position where they can use creativity to solve problems, not repetitively do rote tasks. We want to decrease, human toil and mischief.
Yeah.
And so we're able to do this over and over again. Now, when you start using Liquibase, you might find out like, well, I didn't like this change and I didn't catch it. And that's why we have our Liquibase Pro offering, where it will do things like quality checks. If you're going to add a table, you might want to put a primary key on it. Maybe we don't like this data type. This is a deprecated data type, and we're not going to do it anymore. And so Liquibase will look ahead and say, this change does not meet our standards. Doing the things that database administrators do, just manually reviewing changes on the ticket, why don't we shift left and put that responsibility on the development team so they hook it up with GitHub Actions or whatever. They'll get an error. Oh, you violated this quality check. You need to fix this, developer person. No problem. We also have some really rich logging in Liquibase Pro. So if you want to connect this with some sort of observability platform that you have to really see what is going on. I see we had downtime because of this change. Oh, great. We can either roll it back with Liquibase or just get a better understanding of what's going on. Also, it's made for large teams. Like I said, we've got a lot of, I guarantee you, if you opened your wallet, you would see a lot of companies that are using Liquibase Pro. Those are the folks that saw value in Liquibase open source and wanted to expand it throughout the rest of the company. So regardless of where you are in your journey to this, again, brave new world of microservices, of cloud native, you can use Liquibase open source to get started. And as you grow and see value in it, yeah, sure. There's always Liquibase Pro to help you on that journey.
You mentioned a lot of things that really touched on some problems that I've had in the past that this would solve. The whole idea of versioning a database, for example, versioning those schema changes, being able to see what the current state of things actually looks like. I remember a problem we had in the past where we did notice there were some slowdowns in an application, and we did a bunch of testing on the development side to fix this problem, right? And we're like, oh, okay, well, it's because we need to index, this particular field and blah, blah, blah. We did all this work, did all the research. It worked great on our machines. It worked great in production. We put load against it. It worked great. And then we sent stuff off to production, and it turns out that database looked completely different because someone, like you said, it was a manual change. Someone had gone in and tried to solve the problem themselves by manually adding indexes here and there. So even though we had our indexes we wanted to add, there were a bunch in there already that should not have been there. So if we had all of this tracked and all of these changes were observable from our side of things, just on the source side of things, we would have known where the problem was to begin with. So yeah, that's huge. Another one you mentioned, the development, when you're bringing someone up to speed, they've got to start with something, and you may have developers at any stage of the game, right? They may be ahead, working on features ahead. They may be on the production version. They may be working on bugs that are a few versions behind. And you need a good way to set up the database for them so that it works for them appropriately. So being able to do that as well, starting from fresh all the way to, getting your versions all the way up to current and later. That's
for sure.
Valuable to me.
Absolutely. Look, somebody's off in a feature branch. They make changes to the database. They need to make changes to the database. They've obviously made changes to code. Okay, great. Let's treat both of those the same. When we merge that feature branch down, we not only want to get the code changes, we want to get the database code changes. And so when you start using a change log with Liquibase, it says, this file has been updated. Now, this change log could be XML, YAML, JSON, formatted SQL. And so regardless of whatever your preference is, Git is really good at looking at structured documents like that. Not so good with SQL, but really good with structured documents, and say, this is new, this has changed. And you can debate on, the developer can make a choice of like, I see, this needs to actually go after this other stuff.
Yes.
Of course, big fan of pulling in changes to trunk into the feature branch before merging down. Feel like I should encourage that. But that makes life a lot easier, where we're starting from a developer's perspective. We don't have, we can decrease cognitive load. The same way that we're doing application code changes with Git and merging. Let's do the same thing on the database code side, and not have this different process, because it's a pain for humans to context switch. I need another process over here. Well, no, you don't. We're doing the same. And there's a lot of value there if we just look at the benefits, the things that application developers have put in place over the past handful of years, past decade. Well, we should learn from that and apply those learnings to the database. And we feel that we've done that with Liquibase.
We shouldn't be reinventing the wheel every time,
it's such a pain. Let's just see how other people did it and apply it to the database, and then go on with our lives.
Yes. Okay. Last question for you. What if something goes wrong? What if I, I've used this, I've used Liquibase, I've versioned everything, put everything out in production. There's something wrong, and there's something wrong with that database change. We see it, we observed it. We need to roll back. Is it easy to do?
Well, certainly. Liquibase has a rollback function. No problem. We can roll it back. If you want to do very specific procedural rollbacks where you're like, well, if I add a column, I don't want you to drop a column. All right. I want you to
That's
do
what I was
something
worried
else.
about. I'm like, well,
Well, you could certainly do that. Liquibase can certainly create a table and you tell Liquibase to roll it back without giving it any directions. Well, it's going to get rid of that table.
it'll do what you tell it to do, I imagine.
Right. And you can certainly get in there and be very, no, I don't want you to get rid of that table. I'd actually like you to copy it somewhere. Or if you're going to get rid of these columns, let's create a temporary table, move over the data, do what we do. Certainly with stored procedures, things like that, that's a lot easier. Go back to the old version. Okay, we're good. That's code. We're not losing data. We're all right with that. But when you put something like Liquibase in place, I would argue that rolling back is really inefficient. I would argue that roll forward is the way to go. And this is something we've learned from our application developer friends. Application developers would much rather, instead of, we push out a release, and we see that there's one thing we messed up on. We got a bug. Does it make sense to get rid of all that other functionality and go back to a previous version?
Right.
Or should we just update that one thing? If we have and that's why we moved to cloud native, right? So we could quickly do these things. Well, let's take those learnings and apply to the database. I would argue that it is far easier to make another change set in Liquibase and push it out quickly, especially if we have this integrated with CICD.
Mm-hmm.
We can make the change, do a quick turnaround with automated testing, looks good, a smoke test if we need, who knows, based on the developers and SREs and everybody's DBA's comfort level,
right?
And then roll forward. I think rolling back is because we were doing things manually. Well, we'll manually roll back. And it just doesn't make sense. Now, Liquibase can certainly roll back, but we don't see our customers doing this. The biggest banks that use Liquibase are rolling forward. That is there. They certainly wanted to, the comfort of being able to roll back. But as they implemented this and started to move through this huge enterprise, they were like, oh no, we're definitely a roll forward company now. Now, it took a while for them to get there and get comfortable with that, but we can certainly roll back, but I would always encourage roll forward.
Makes sense. That is comforting for me to know.
It's still scary. Still scary.
Sometimes things go out and you don't know right away what the problem is, but you see the problem right away.
Well, absolutely. That's one of the reasons why we released the observability updates this year. We wanted to make sure that companies that were using Splunk or Datadog or something like that, whatever you're using, that you can get insight into database changes. You're getting insight into code changes. You're getting insight into these other things. Well, let's add this as well. And being able to have that, and I hate the term, but I'm going to use it, single pane of glass, to look at this stuff. We need to quickly get data to people so that they can make the right decision.
Yeah.
And be able to make these updates quickly. I don't think that's unreasonable. And it's amazing what happens to organizations when there's a lot more transparency between teams. There's this wall, culturally and technological wall between development and our DBAs. And that causes friction. It causes, there seems to be a disconnect between the two teams, and that ain't no way to live your life. And so we're hoping that with Liquibase, we can empower developers to make these changes, but at the same time, enforce the same standards that DBAs want. Because both of them are doing valuable things for their company. So let's help them both out.
Makes sense. Well, I'm excited to try it on our project. I think that it's something that we want to go ahead and pull in and start using, see how it works. We're going to start with the open version first.
Of course.
check out the features, see what's there, see what's possible. And yeah, I'm looking forward to it.
Well, good. If there's anything we can do to help, the answer is yes. You know how to find us.
Awesome. Well, thank you so much, Robert. I really appreciate you talking with me about it and sharing what you know. And hopefully someone else out there will benefit from this conversation too.
Anytime.
Well, that was cool. Robert's a pretty cool guy. I think we're set on trying this out, and let's go ahead and move forward with it.
Great.
So next on our plate, next on our plate, we have our security fixes that we want to do.
Yes. Yeah, the security is always the big one, because there's, so many different layers of it, right? It's no longer is it that, the security is that thing the network guys have to worry about, and everybody else just, builds their apps and does what they need to do, with the whole shifting left, as everyone says, and moving the security in different places. And also it's just, there's different layers of it. So there's obviously the WAF, or, whatever firewall you have that's sitting at the very front, which is very important, to catch those things. But then there's also, there's things that can't necessarily catch. What if you have a CVE or something that's back deep in the code base, but you don't just want to set it out there, and you don't necessarily want to rush a fix in. So this is where it comes in, when you can do the fun things of, putting mitigation efforts into place. So, doing it at, closer to the front door, right? Trying to get something where, for example, like going back to the, Heartbleed vulnerabilities that were back however many years ago now, man, it feels like forever. But, for example, it was a vulnerability that, it wasn't in NGINX per se, it was in the OpenSSL libraries that were leveraged by that. And obviously we couldn't patch that, but there was ways that you can manage the configuration to not allow that vulnerable part of OpenSSL to be leveraged. So being able to roll those mitigating factors out and, kind of buy yourself some time so that you're not rushing a code fix just because, you got to stop the, hole in your security, but instead being able to make sure that you're secure and work on a patch at the same time to fix the core issue. Because it really is just that, you got to get it blocked, right? It's like a hole in the bottom of your boat. You got to fix it. Right. But you don't necessarily want to do the permanent fix when you're rushing around trying to, even wrap your head around what's happening.
Right. Yeah, that makes sense. Yeah, that's really highlights the importance of, your development team communicating with the team that actually, does deployments, being able to have that channel open so that you can protect yourselves better and decide on your plan of action.
It is really one of those things that I've personally found has kind of helped break down those, walls between the different groups. Cause I know it was always kind of, in the past, it was kind of a, butting heads between your system side and your operations people, and then your developers, because, it's always the other person's fault. Right. But, now with these teams, there's so much more collaboration and working together, because even if you're an operations person, most of your work is still being done as code. So you're still checking stuff into a repo and running through that same CICD pipeline, except it's not for the application code. It's for your infrastructure, right? It's for your networking. It's for all of that stuff. So it's definitely helped the collaboration between those two groups, I think.
Yeah. On the development side, when you do get the time to actually fix the problem after you figured out what the mitigation is, code side, this is something that has come up time and time again for me in my career. We have something like this, and I'm going to wrap up not only just security updates that everyone is concerned about, but just regular updates that, you need to keep up with libraries and with packages that you're using, because eventually the maintenance of those goes away because everyone, wants to keep up with the latest and greatest. And there was a period of time when I was definitely one of those who would sing, if it's not broken, don't fix it. But since then, I've learned a thing or two. And you really do need to keep up with these things so that when a security issue does come out, it's a much easier upgrade, right? I mean, it's pretty tough to upgrade from something that's 4 or 5 versions ago to the latest, right?
Yeah. And especially when you run into those similar situations where maybe you don't even necessarily know how it all works, right? There is that, not only like it's not broken, don't touch it, but also we don't really know what's holding that together. So if you touch it, it might break and we got no clue what to do. So, instead of, kind of putting your head in the sand and hoping that it never breaks, it is kind of good to go in and break it, right? Figure out how you're going to do that, because chances are you're in a better position now to break it and figure out how to make that upgrade than when something goes completely sideways. And again, you're in that high pressure situation and now production's down.
Yep. Yeah. Now I recommend teams to always have I hate to say backlog because it makes it sound like low priority. Yes. We need a different name for that, but always have a list of items that can be done perhaps in tandem with the feature, but sometimes it might be better just to have a full-on sprint where you just focus on upgrades and that's it. But for every sprint, I think it's important to reserve time for stuff like upgrades. It can't just all be features, right? Or all bug fixes. You must do that maintenance work every single sprint.
Yeah. And I've seen some ways I've seen it work well is where it's kind of each kind of person on the team is in a rotation, right? So there's always one person a sprint who it's kind of doing the housekeeping stuff, and it's like everything else. It's like, keeping up your own house. If you do a little bit every day, it's a hell of a lot easier than waiting a month and then trying to, dig yourself out of a giant hole, the giant mess.
Right. This is a little bit different context, but it could be used the same way. You can make this fun too, this rotation. We had a person on our team at one time that we labeled Batman. They were Batman for that sprint. And we even, got the cape. So they got to wear the cape on their chair. So they were the ones that would deal with any, critical issues that came in during the sprint. And they were not responsible for any feature work or any planned work. Yeah. They were only focused on stuff that, came in an emergency. I think that same concept could be used for maintenance work too.
Yeah, no, I think that's a great idea, because it's always that, you never want to have the, full all hands on deck, right? Because then, it's easy to go like, oh, we can't take an entire person out of this feature work, but it's like, well, it's better than taking the whole team out when something comes up and all of a sudden we need to shift gears. So having that dedicated person, whether it's, cleanup or just being ready when something goes sideways, or, kind of a little bit of both probably too.
Yeah. I think we've covered the code updates we want to make. Are there any infrastructure updates we want to make?
Yeah, I mean, I think, in infrastructure, it's the same sort of thing. We always got to figure out, when do we update that too, right? And how do we update that? It's one of the fun things with Kubernetes is it makes these sort of the application updates very easy. But what about your cluster, right? You're going to run into the same things, and sadly, in place, while it's theoretically possible, right? Just like everything else, you can upgrade your existing one to a new version. In my experience, it's always been beneficial to start from scratch, right? And that's one of the other great things, like I was saying, with the operations side also working in this CICD pipeline. That's where you can do that, because you can automate the building of a whole new cluster and then use that tooling. And again, just like we were treating the application, slowly move traffic over so that you're not going, okay, everything's getting updated upgraded right now. You can stand up your new version right next to your existing version, slowly move traffic over, do all of your testing, do your pre-testing internally, slowly start moving traffic over. And because you're doing them side by side, the rollback's even easier. You just point all the traffic back to the old cluster and you're good to go. So I really do love this thing, like I was saying about, kind of breaking down those walls. It really lets you treat your infrastructure like your application. And you can just go ahead and move that, because you're not having to go and manually build a new server and rack it up. And, because we are running in a cloud-based environment, obviously, yeah, it gets a little bit more expensive. Obviously, you're doubling your infrastructure costs. But if you do it in as, you have it automated and you have your testing running, you can do it pretty quickly. And I think whatever you may lose in cost and price, you're going to save in potential uptime, because you're not trying to do it all at once.
Yeah, that makes sense. And, this planning ahead, we know we're going to have to do this.
Yeah.
So we should go ahead and set ourselves up for success and ready for it in our testing environment so that we can get it in our production environment. Yeah, this is a good plan. I think we should do that too.
I feel like it's very similar to, building the test plans in your application as you're building it. At the time, it seems like extra work and it makes it take longer. But at the end of the day, you're saving yourself time in the long run. And I've always thought the same way when it comes to infrastructure. If I know I'm going to have to do it more than once, I'm going to automate it the first time, because then when I need to go back and do it again, it's already done. Maybe it needs some polishing. It always needs some little bit of attention and care to keep up with all the different versions of everything. But if you're starting from something that it's going to at least work at a certain extent, it really just saves you time in the long run.
Yeah. Well, I'm excited. I'm excited to go implement some of the advice that we've gotten today. And next time, let's talk about observing what we've done. We know we want to make updates, but how do we know that anybody cares, or that, that our system is working well for us so that we can repeat it in the future?
Yeah. Or, having the ability to see where there is a problem in the application too, because
exactly.
Hopefully it's something that you can pick up before it's everything's on fire and everything's offline, and you can pick up that little breadcrumb before it gets too bad.
Yeah. Beautiful. All right, let's go off and do this. We've got a lot of work to do.
Yep. All right. See you later.
All right. See ya.